Okay, welcome folks to the last part on algebraic fractions, equations and expressions. This is presented by Sparkkk, and please remember to like, share and subscribe to the channel so that you can always receive latest editions should they be ready. This time around, let's close with 10 similar problems again. First problem, we're interested in the LCM of 3x and 9x. So what we'll do is we'll look at the coefficients. They are 9 and 3. So the LCM of 9 and 3 is going to be 9 itself with their multiples. Then for the variables x and x, we take the smaller degree. And for this case, both degrees are 1. So we just take x as our smaller degree. So the LCM becomes 9x. Then next, we want to simplify a fraction there. It's our algebraic fraction. But what do? We can see that there is a on numerator, a on the denominator, and they have the same degree, meaning they just cancel each other. We end up having 10 divided by 5, which will give us a 2. Then next we want to perform an addition. If we check our denominators, they are both of the same degree, implying that would be the LCM itself, which is 1. So we simply simplify the numerators, which is 2 plus 5, giving us 7. Then moving to the fourth problem, again, similar to the previous one, if we check, we've got b and b on the denominator, so it happens to be our LCM itself. Then we simply simplify the numerators, this 8 minus 3, giving us a 5. That will be our solution there. Still moving, we now have a slightly different scenario where we have got 2x and x, and we are looking for LCM. And remember, when there is no number, we know the coefficient is 1. So LCM of 2 and 1 is going to be 2. And for x and x, we said it's x itself. So that's our common denominator, or LCM. Now, when I divide 2x by 2x, it gives me 1 times 1 on the numerator, 1 plus. If I divide 2x by x, I get 2 times 1 on the numerator, that's 2. So if I simplify the numerator, it's 1 plus 2, it gives me 3 over 2x. I think that will be our final solution. Then next, we want to define an expression. So it's a sum or difference between algebraic terms. So in other words, these terms, they involve maybe letter 1 or 0, name it. Then moving to the seventh problem, we're interested in solving a linear equation. Here we can try the change sign rule, where we are saying when negative 6 crosses, will remain with x here, equal to in front of 11, we'll now have positive 6. So x will actually be 11 plus 6, it gives us 17. Then next, we are solving 3x equal to 18. And in this equation, we are looking for the value of x. So to get rid of 3, because it's a product, we will divide by the 3 itself. But because there's an equal sign, whatever we do one side, we also do the other side, because it's the balance method. When I have 3 on the numerator, 3 on the denominator, they cancel. I'll remain with x, and the other side is 18 divided by 3 to give me 6. Therefore, the x which balances that equation is 6. Then next, you want to solve for x again. Then 2 must transpose or cross the equal sign. So that we remain with 5x being equal to 17. In front of 17, we have negative 2. Then in the end, when we simplify, 5x will be 17 minus 2. It will give us 15. Then I divide both sides by 5 so that I remain with x only. When 5 and 5 divides, we get x being equal to the other side is 15 divided by 5 to give us a 3. Then the last problem, we're interested in an explanation of the balance method in our words. So we can say because an equation has an equal sign, for the equality to be maintained, whatever we do, um, let's see, whatever we do arithmetically to one side comma applies to the other side. So the aim is to maintain the equality between expressions. Now, things to note as we progress with our studies, we need to be able to follow correct algebra steps, also clear simplifications, proper equation solving process, logical explanations. I think that's it, folks, for algebraic fractions, equations, and the expressions. So remember to like, share, and also subscribe to Sparkkk so that you can continue to receive notifications to more recordings be done. Bye for now, folks.